Hey guys, I'm very excited about this video. This thing has been on my bucket list for quite some time now. I'm going to show you how I built this CNC router controlled by an Arduino for around $600. I decided to build my own rather than buy one for a few reasons. The first is it sounded like a lot of fun. The second is I wanted to save money, and the third is I wanted a rather large cutting area. Another great thing about making your own CNC router is that you can rely on freeware, such as this universal G-code sender, which I will be using, which connects directly to the Arduino. All right, let's get started with this build. As you can see right off the bat, there are a lot of things that need to be purchased, but don't worry, I will leave a link for each and every one of these items in the description below. I decided to build the frame using extruded aluminum. I know that a lot of DIY YouTube videos out there show people building their CNC router out of plywood, and I just thought that this would be much easier to work with for those who don't have a lot of wood tools. This is really easy to put together. It's very straight and accurate and rigid, and I think he will end up with a better product here. You can see by the end profile here that I'm using 2040 aluminum extrusion. And the first thing I'm going to do is take one of these 1 meter pieces here and cut 4 legs. For cutting the legs, I'll be using my wood miter saw here. I've set up a stop block about 6 inches away from the blade in order to get repeatable cuts for all 4 legs. And as we're cutting aluminum with this saw, be sure to wear proper eye protection and cut nice and slowly. Next, we'll attach the legs to a full 1 meter long side rail using hidden corner brackets. Next, we want to install our linear bearings and rails onto the side of our frame. This is a 20 millimeter by 1 meter linear bearing set. To install the rail, we're going to use some of these 6 millimeter slot nuts. Put one there and feed one up through here. And then we can install our rail just like so. And we'll want to line this edge up flush on both sides. Okay, so the next thing we need is our gantry plates, which will connect our 2 linear bearings together. And you can make this out of plywood. I chose to make it out of 1/4 inch aluminum plate. And in order to build this, I built a template. So the idea here is to tape the template down to your sheet metal plate and use a spring-loaded punch like this one to mark the exact location of all of these holes. That's what's most important, is getting the holes in the right position with relationship to themselves. And then you can also mark the profile out, which isn't as important. Now, I decided to countersink my holes just because I am using flathead screws, but that is completely optional. Just for fun, I threw on a little shiny metallic paint. Next, we'll connect the 2 gantry pieces using a 1/2 meter piece of 2040 aluminum extrusion. For this step, you'll need to cut some threads in the end of your aluminum extrusion. This stuff is sized perfectly for a 5 millimeter tap. To add rigidity, I'm going to add some of these corner brackets. You'll notice these have little centering tabs on them. In order to get it flush with the gantry plate, I took a file and ground those off on one side. So right here I've installed a temporary brace just to hold this thing up while I attach the gantry plates to the linear bearings. Alright, I moved my temporary support to this end so I could check out that everything slides correctly. Next thing I'm going to do is make some cross supports. So I'm going to take a piece here and scribe a mark where I need to cut these. So here I've cut all 3 pieces the exact same length and installed each one with 4 hidden corner brackets. I also installed some exterior corner brackets in the 4 corners. As you tighten everything up, you want to make sure it's all square, and tighten everything incrementally, you'll get a better outcome. Now here's the lead screw assembly that we're going to be using. This one is actually slightly longer than 1 meter. The only thing I've done different is I've added 2 of the corner brackets, and as you can see, I filed off the guide pins so that it'll sit flush against our gantry assembly. Here it is, installed nice and square near the center of the gantry assembly. You'll notice the ends are not connected to anything yet. To hold up this end of the ball screw, I cut another piece of aluminum and installed it with some hidden corner brackets. We want to leave everything loose though until we slide the gantry assembly down to this end. Of course, this is always the fun part. Pretty similar down here on the motor end. I moved the gantry down to this end, installed another piece of aluminum in between the legs, and then bolted the bearing assembly to that piece of aluminum. Everything seems to be moving nice and smooth. For the motor mount, I had a couple pieces of scrap aluminum that I cut about 5.5 inches long. You can see I've put corner brackets on each side. And there's 2 of them with a little piece in between. You had to find some smaller angle brackets to go in between there. But this is very adjustable. You can slide it back and forth, in and out, and it should work good. It's really rigid, so it should work great for the motor. With the stepper motor installed, our X-axis is complete. Okay, next I've cut 2 14-inch long pieces of extrusion, and these will be for extending the gantry rails. As you can see on this side, I've already pre-installed all of the fasteners so that I can just slip this on and tighten them up. All right, next I've installed a full 1/2 meter piece of extrusion to match the one on the bottom so that everything turns out nice and square. The next step is to cut and install the wasteboard. There's no particular size this has to be. I just left a little space between the gantry and the wasteboard so that there's no interference. I use these pan head machine screws and pre-installed the nuts. You want to make sure you oversize these holes and countersink them so that it's easy to install. With the spindle assembly installed, this is really starting to look like a routing table. You want to make sure that you install these rails the same height above the deck here. What I did is I used a piece of paper as a shim, make sure it could slide all the way back and forth. I just installed the lead screw into the Y-axis, and in order to get this spindle carriage all the way to the side, I've made a little spacer out of a block of wood. And similarly, on the other side, to hold the other end of the lead screw, I've got a block of wood. Once again, I made some templates that can be used for making these blocks of wood. And here are the screws that I used to install them. And just to clean things up, I'm going to cut the lead screw off so it's not sticking out of the block. You'll notice this carriage has an anti-backlash nut in the Z direction, but does not come with one for the Y direction, so you have to buy one separately and put it in there. I've bought this round one. Won't need this piece here at the end, just use the spring and the anti-backlash nut. But as you can see, we've got a round nut for a square hole, so I'm going to have to cut the corners off this so it'll fit down inside there. Just like this. Here I've attached a scrap piece of plywood to the back of the gantry to hold the electronics. Here I've installed all of the electronics on the back of the gantry. This is the 36-volt power supply that powers the X, Y, and Z stepper motor controllers. This is the spindle power supply, and this potentiometer comes with it. You can adjust the speed of the spindle. I decided to put an AC switch in here so I could turn it on and off without having to unplug it. These, of course, are the stepper motor controllers. They are tied to the 3 stepper motor controllers and to the Arduino, which is our brain of this operation. We also have a relay here that's tied into the Spindle enable control on the Spindle power supply. So the code will be able to turn the spindle motor on and off. So this one here I'm calling my Y-axis control, which is going over here to the side of the gantry. The center one here will be my Z control, and it comes up and over to the stepper motor for the spindle. And the one here on the left is for what I'm calling my X-axis. It loops around down here, goes into this cable raceway, and all the way back to our X motor. Here's how I set the limit switches on the stepper motor controllers. This first one here is the Y-axis. Here's the Z, and back here is the X. With the mechanical and electrical installation complete, the next thing to do will be to flash our Arduino Uno with the open source GRBL software. Alright, so that's it for this first video. In the next video, I'll show you how to download the software for the Arduino, how to download and install the universal G-code sender software, as well as configure it for the right settings for this machine. And we'll also go into Fusion 360 and build our first part. As always, thanks for watching.